Hey everyone, so today we are going to start with the destructor in C++. So without wasting time, let us start. So a destructor is a special member function which has certain properties. So let us go through these properties one by one. So it is called automatically when the object's lifetime ends. Whenever the object goes out of the scope, the destructor is called automatically. It cleans up the resources, memory files, logs, sockets, etc. It has the same name as that of the class, and it is prefixed by a tilde sign. It does not take any parameter and it does not have any return type. And only one destructor per class is possible. You cannot overload the destructor like what we were doing in constructor. We can overload multiple constructors, but we cannot overload the destructor. So let us see one by one how the destructor is called and in what scenarios it is called. Let us go to the Visual Studio. I'll create a file demo.cpp. Now the first thing that I'm going to do is to create a class which is having a destructor and a log which is going to be printed inside the destructor. So class A, in the public section, we are going to have a destructor. Inside this destructor called, I'll just have this log so that whenever we are going to call it, we can see on the screen whether it is called or not. Now I'll create a function, say void func1. Inside this, I'm going to create an object of A type. Now we can see that the scope of this function is till this block only. So when the function ends and the object goes out of the scope, it automatically calls the destructor. So if I'll just say int main, and inside this I'm going to call func1 and return 0. Now let us try to compile it. So g++ demo.cpp. Let us say dist. So it compiled successfully, and if I'll try to run it, you can see the destructor is called. So whenever the object goes out of the scope in the local function itself, it calls the destructor. Now, what happens if I'm going to do a dynamic memory allocation? Say I have a pointer of type A where I'm going to assign new A. Now in this case, we are just creating an object of type A and we are saving its pointer. So if I'll try to compile this now, it will compile successfully. If I'll run it again, now you don't see the destructor being called again, even though we had created an object of type A. Why? Because whenever we create an object dynamically, then we have to handle the destruction of that object ourselves. So to delete or release the memory, we just have to call the delete P. Now if I'll try to compile this and let us execute this again, you can see the destructor is called twice. So while programming, have you ever seen this? Yes, you might have seen this when you were using a vector. At that point of time, you would have seen that. So I'll just put a comment. This is stack behavior, dynamic allocation, and now we will come back to container elements. So let us say we are going to create a vector of type int or vector of type A, say v. So I have to include the library first, hash include vector. Now, since we have only created a vector, you must have called a clear function over this vector. Sometimes while programming, you would have called clear. So what this clear function does is, on each and every element which is present inside the vector, it is going to call the destructor for it. So right now, there is no element inside vector. If I'll compile it and try to execute this, you will see the locking twice, which is for the above two, not for the container. Now if I'll just insert few elements, v dot pushback, let us say we just inserted our object P, but it was already deleted. So what I'll do is I'll create another object, and that was also giving us an error because P is also a pointer to an A. It is not actually an object, it is a pointer. So I'll just create an object, A obj, and I'll insert obj here. Now if I'll save it and try to compile this, you will see the destructor call is there, but it is 4 times. Why 4 times? Because the first one is for the stack behavior, the second one is for the dynamic allocation, the third one is for the container. So when we created an object and we push back that object inside the vector, when we called clear, it is going to destroy that element which is inside the vector. But what we have created in our main function, this obj, is going to be destroyed once we are going out of the main function. So that's why we have got destructor call 4 times. So hope you have understood why we have 4 calls for the destructor. Now there is one more way you would have seen, which is temporary object. So how a temporary object is going to behave? Say if I'll just call the constructor over here. I have not done anything. I have not saved the object anywhere. I have just created that object and just released that in the same line. So in the same expression, it is going to allocate the memory and then deallocate it. So if I'll just save this and try to execute, you can see the destructor call has increased by 1. That is because when we created a temporary object, it got created and in the same line it got destroyed. Even though it is temporary, it will call the destructor. So this was the basic behavior of a destructor. Now let us go in depth that how a default destructor can be written inside the code. So I'll create another file, say demo1.cpp, hash include iostream. And this time I'm going to create 2 classes, say class A, which is going to have a destructor which is empty. So this is a user defined destructor. And there is a class B, which is having a destructor, but this time I'm going to assign it to default. So both of them mean the same. So both of them mean the same. So what is the difference? The difference is that this is a user defined destructor, whereas this is user declared destructor. Here in this case, you are still going to get a destructor which is provided by the compiler, whereas in the first case, you are not going to get any destructor from the compiler. But you should remember one thing, that in both these cases, since you have declared a destructor, so it suppresses the implicit move constructor and move assignment operator. Since you have created a destructor or you have declared a destructor, so you will not get a default move constructor or the move assignment operator. You have to define it on your own. Now, there are few tricky questions that interviewer might ask you, that can a destructor be inside the private section? Yes, a destructor can be in private section, and you can see in the code itself, the destructor is in the private section. So when do we use such kind of destructor? We use it in the case where we want to control the lifetime of the object. Along with this, I will also share one more thing, that you can also delete the destructor. So a class C, where I'll be creating a destructor, but I'll just call delete. So now the destructor will not be available. Okay, this has to be C. So now the destructor will not be available. So you cannot destroy the object. So in what cases is this really useful? When does a private destructor is useful and when does a delete destructor is useful? So in most of the cases, they are useful when we are trying to handle the lifetime of the object. So it is used in case of singleton, pattern you can say, also for static only classes. So if you have only static members, static functions and static members inside the class, then in that case, you don't need to create the object of that class, right? So in that case, you're going to delete the destructor. So depending on your use case, since all of the members are static, so you can directly access the members through the class instead of creating an object. It is also heavily used in factory pattern, because in factory pattern, we try to control the creation and the destruction of the objects. So let us see them one by one, a few of the examples, how we deal with these. So let us first go with the factory pattern itself. I have also created a separate video for the factory pattern, so you can go through the video. The link will be in the comment section. But To an add-on to that pattern, I'll try to explain how the destructor can be used inside the factory pattern. So again, we are going to have a class, say class A, and inside this class A, I'm going to have two functions in my public section, and both these functions are going to be static. Static, I'm going to return the pointer of my object, and the function will be to create the object. Now inside this, I just have to return new A. So it is going to return a new object, whereas there will be another function, static void destroy, which is going to take a pointer P of the A class, and I'm just going to call delete on P. Now this is going to delete my object. Now we don't want anyone else from outside should be able to call the destructor by themselves. We want them to call the destroy and create function only. So in the private section, I'm going to keep my destructor. I can do this, or based on your need, you could have also deleted it. So that is one thing. The second thing is you can see that we have only the static functions. But in this case, we are trying to manipulate with the object itself. Say if you have some class B, where you just have certain static int x, and you are trying to manipulate the data of this variable. So static at void set value, it is going to take an int value, and you have a static int get value. They are just kind of getters and setters. You are going to return x. Now in this case, you don't actually need to create the class B object because everything inside the class B is going to be static. So you don't actually need to create the object. So what you can do here is, instead of allowing anyone to create the object, you can just delete the destructor. So that's simple. So in this case, you can see the deletion of the destructor is also useful. Now the same thing also gets applied to the singleton pattern, where we try to maintain the life cycle of the object because we only want a single instance to be there. So instead of giving the access to the outer world, we try to maintain few functions and keep everything as private so that no one else can deal with the creation and the deletion of the objects. So hope you have understood how to use delete and default. Now let us also dive into one more tricky question where interviewer can catch you. So let us go back to one of our example to our demos. So let us come back here. So here we have class A and B. So for now, let us make it user defined, and we are going to create a function inside my class A. So void func1. Func1 is going to take the pointer of B. So we can just say B. And I want to delete this pointer inside my class A. So delete P. So right now it is giving us an error because we have the destructor in the private section. So we'll just move it to public. Now, since it is public, you won't see any error right now. But there is one error which we can deal with in the current state only. But let us first run this and see what is the output. So if I'll just execute this, it says that B has not been declared. Why? Because the class B's definition is below class A. So I can fix that error. It is easy that we just have to give a forward declaration to B. So now this should work, right? If I'll try to execute this again, you will see that it still does not allow you to use the delete operator. And in the error, you can clearly see that it says neither the destructor nor the class specific operator delete will be called even if they are declared when the class is defined. That is because the compiler will not allow you to do this. Because when you give the forward declaration, the compiler only knows that a class B exists, and the compiler will be able to find the class B. further. But it does not say anything about the size of the class B, whether the class B has a destructor, whether the destructor is virtual or not, or what members does it contain. All this information is not provided to the compiler when you provide a forward declaration. So that's why it will not allow you to call the delete operator on the B class pointer. So to fix this, I can easily just move the class B over to class A, and it will be able to find the class B first. So after the compiler sees the class B, you can call delete on class B pointer. So if I'll try to compile this now, okay, we don't have a main function. So I'll just create one int main, and we'll just return 0 simply. Now if I'll try to compile this, you see it compiled successfully. So this is one more concept that you should remember, that the definition of the class should be visible to the compiler before you call the delete operator on that class pointer. Now there is one more concept, a concept related to the constant functions. So let us for now comment both these classes, and we are only going to deal with the class B. So we have a destructor. Now inside my main, what I'll do is I'll create a constant A object. I can do this very easily by just putting a constant keyword. Okay, we have the B object. So I created a constant object of type B. Now I can only call constant functions using the constant object. So I can create a void func. To show you, I'm not going to make it constant for now, and we are just going to see out function called. Now here, I'm going to call the func. So we got an error that the object has type qualifiers that are not compatible with the member function. If I'll try to compile this, so you can see we got an error. So basically you cannot call a non-constant function with the constant object. If I'll just make this constant, and now if I'll try to compile this, it compiles successfully. But the important point that I want to show here is the destructor is not a constant function. You can see we don't have a constant keyword written over here, but still the class object will be able to call it once it goes out of the scope. If I'll just add on some log, see out destructor called. And now if I'll try to compile this, let us run this. And you can see destructor is also called, even though it was not a constant. That is because the destructor has special privileges. The compiler provides special privileges to the destructor that it can be called even on the constant objects. Now let us say if you have a data member inside this, say int x, then in that case, you cannot modify this variable inside your constant function, because constant function can only modify L values or the constant values. So if I'll just write it x equals to 5 over here, it will not be allowed. It will give you an error that x should be constant. But if you write the same thing inside the destructor, then it will allow you to do this. It won't give you an error. So you can do this inside the destructor and it is completely allowed. But right now you can see we have got an error. And if I'll even try to compile this, this might give me an error. So I've got an error that is compiler dependent. Sometimes in Visual Studio and IntelliSense, it shows that if you're trying to create a constant object, then the members which are inside the class should be initialized. It gets confused, but ideally it is not going to happen in all the systems. So just to remove the error, what I can do is I can just create a user-defined constructor and leave it empty. Now if I'll try to compile this, it will compile successfully. So I hope you would have understood a lot about destructor today and many concepts that you might not have seen till now anywhere being explained. So these are few tricky questions that sometimes interviewers ask you and you get confused while answering. So if you're still confused, you can watch the video again, and if you have any doubts, you can ask in the comment section. I'll be happy to reply. And thank you so much for watching the video. Do like and subscribe. Thank you.